In this video, I'll show you guys one of the most infamous type of the questions in your Cal 2 class, namely how to calculate the work that we need to pump out the water from a tank. This is infamous because you know this is pretty difficult, but it's okay because I'll show you guys my ghetto way to explain this setup right here. And hopefully after my videos, you will see that this type of questions, they are not that bad at all, okay? First of all, we have this tank right here, and the water level is from here to here, and we have all the dimensions ready on the board, okay? And one thing you have to pay attention is that we are in SI units because we're using meters, okay? And now we have to talk about what is work. So let me write it down right here for you guys. Work is defined to be force times distance, but let me put down the distance first. So let me put down work is the same as distance times force. And now, what is force? In many situations, force is just the weight of the object, right? So the force is just the weight, okay? And now, how do we calculate the weight? For example, how would you calculate the weight of this microphone? Yes, this is my microphone. First, we have to know how big this microphone is, right? So that's the concept of the volume. Second, we have to know what is this microphone made of. Namely, we have to know the density, right? Because you can imagine, if this is made of gold, I'll be rich. No, never. If this is made of gold, this is going to be really heavy, right? So, two things. One is the volume, the other one is the density. Let me put this down first as we have to know the density, okay? And then we have to multiply this by the volume of whatever the things that we have, right? So this is how we can figure out the weight, okay? And now, as you can see, the weight is the density times the volume. And I will put this down all together. The work is equal to distance times the density times the volume. And this is like the blueprint that we're going to follow. And the hint is that the volume is actually the hardest part. That's the part that you have to do the math. And we'll figure this out first. And we're going to do this from right to left. And you'll see what I mean by that in a minute. But this is what we are going to follow, okay? Okay, now refer back to this picture here. We have this circular cone and it's upside down. And we have the water from here to here. Well, to pump out water, this is what we have to do. Because at different level right here, the distance will be different and also the volume of the slice will be different. Here is the deal. In the textbooks, they may show you how to use a similar triangle whatsoever, but I don't recommend you guys to do that because it's not consistent. Sometimes they will show you by using geometry, by doing some similar triangle or whatsoever. I like to do algebra much better though. And this is what we have to do in order for us to do algebra, to come with equation and things like that. First, we have to set up our reference frame. Namely, we have to put down the x and y axis. And we have choices. We can put down the x-axis right here on the top of the tank, or right here on the top of the water level, or right here down below all the way on the bottom, all right? I'm going to set up my reference frame with the x-axis here so that I don't have to deal with any negative y values. And let me do that right here for you guys first. So, once again, you have to set up your reference frame first in order to do algebra, okay? So, this is my x-axis. And of course, I will just cut this right in the middle for my y-axis. So, this right here is my y. Like that. Okay, good. And now, this is a circular cone. When we make a horizontal slice, each slice is going to be a cylinder, a small cylinder, right? You can see from the picture right here already. And that's just like a CD, isn't it? And yes, this is a CD. Maybe you haven't seen a CD for a while because we don't use CD nowadays, right? But this is one of my teaching tools actually. And perhaps I can ask you guys, does this CD have a volume? Yes, it does. And how do you calculate the volume of the CD? Well, you have to know the area, so it's pi r squared and times the thickness of the CD, all right? So let me put this down right here for you guys on the side. This is just my note. The volume of a cylinder, this is technically a cylinder, right? Because if you don't think this is a cylinder of 1 CD, it's okay. How about when I have bunch of CD, and now you can see that this is a cylinder, right? And when you just have one, this is of course still a cylinder, but it's just smaller. Anyway, to calculate the volume of this disk, right, the CD, we need to know the area, which is pi r squared, and we have to multiply by how thick this is. And usually people say this is the height, but because this is really thin, right? And when we make a horizontal slice, it's meant to be a really small, really thin slice. So I will put down pi r squared times thickness, okay? So that's how thick the CD is, okay? So that's the idea. Well, let's figure out the volume when we make this horizontal slice. First of all, as you can see, this is just like a CD, and our first goal is to figure out the thickness, okay? For the thickness of this disk right here, well, actually the small cylinder, well, this right here, it's a small change amount in the y-axis, as you can see that right here, right? Let me just make this in blue so you can see better. This vertical distance is just a small change amount in the y-axis, so that's labeled as dy. Okay, now the volume, as I said earlier, we'll work this out from right to left. Even though it's math, yes, we do it from right to left. Volume, for the thickness part, I will have the dy, okay? And then we have to have what? R squared. Well, what's the radius? As you can see, radius is just the horizontal distance, right? From this picture right here, the radius is just from the y-axis all the way to here. This horizontal distance is the x value based on our reference frame, right? So this is just x, and that's the radius of this cylinder. So we will have to multiply by x squared, and of course pi is just a pi. And guess what? You are done with the volume of this blue cylinder, all right? So it's just like the CD that we have. Next, we are going to figure out the density. And this is actually really easy because they are just constants. First of all, you do have to remember, we are in SI units. We have to multiply the density of the water, which is given. So we have to multiply by 1000. And let's just forget about the unit for now. Let's just focus on the number, okay? So we have to multiply by the density of the water, which is 1000. So let's put that down, 1000, okay? And here is the matter when we are in the SI unit. When we are in the SI unit, we have to multiply by 9.8 for the gravity constant, okay? So we multiply by 9.8. All this right here will tell you the density of the water, okay? And now, here is the distance part. Okay, pay attention to what we have right here. This is the CD that we have. And our goal is to figure out what's the distance that it has to travel from here all the way to the top so that water can be out of the tank, okay? Once again, it's from this CD here at this place all the way to the top of the tank and then out. Now, based on the picture, from here to here, right, from here to here, as you know, this part is a vertical distance from the x-axis to here. This is just the y value. Yes, earlier this distance is the x value, and from here to here it's just the y value. And excuse my picture, it's not 100% like perfect, but you know the idea. Anyway, from here to here is y. Well, I don't want to know y. I want to know from here to here. So I need to figure out the distance all the way from the top of the tank to my CD here, okay, to this disk. So it's like this. How do we do that? The whole thing is 10 meters, and from here to here is y already. So that means the distance I have to travel is just going to be what? 10 minus this, 10 minus y. So that's the distance that we have. So let me label that for you guys right here, okay? So the distance is just going to be 10 minus y. And now, what this is that this is the work that we need to pump out this slice of the water in this kind of circular, cylindrical kind of shape. Pump out this much of the water from here up to the top to the tank, all right? And now, how many of this kind of disc, how many of this kind of CD do we have? A lot, infinitely many, right? Here is the integration part. We are going to integrate, and at the end, we just have to look at, here is the first water slice, right? So this is when y is equal to 0, and the water is stopped right here. From here to here, as you know, the whole thing was 10. The top 2 meters is empty. So up to here, it's 8. Okay? So we go from 0 to 8. So this is the water level. So this is all the possible CD that we have. And now this is pretty much the work. I will just abbreviate this with W. This is pretty much the idea. Okay? We add up all the possible CD like this, and then that's pretty much it. Unfortunately, there's one thing that's not invited in this integral. What is it? The x. Why? Because we're in the y world. Okay? Now, we have to refer back to the picture and do more math. Then what kind of math can we do? Well, let's see. This is the x, this is the y. On the side, if you just look at the cut right here, this is just a straight line. So let me just darken the straight line right here with my marker, okay? We must come up with a relationship between x and y so that we can replace the x into an expression in terms of y. Well, this is just a line. Pay attention to, this is the x-axis that we have, this is the y-axis that we have, and this is a straight line. Well, back in algebra, this is just like the good old days. How do we find an equation of a line? Well, first we need a slope and things like that, right? Okay, this right here, we have a first point, which is, of course, 0, 0. And then this point is what? Be careful, you do the x value first. So from here to here is 4 meters, right? So this point here is 4, comma. The y value is from here to here, which is 10. So we have 4, comma 10. And now, I'll just do the algebra right here for you guys. Let's get the slope first. M is equal to y2 minus y1, which is 10 minus 0, over 4 minus 0, right? x2 minus x1. And then this is just 10 over 4, which is 5 half. And now, you can do this, y minus y1. And let me just remind you guys how to do the easy things, like the things that we used to do, right? Because back in the days, when we had to do just this, we didn't even have to study and we can still get an A, right? Anyway, this right here, I will just label this as my x1, and this right here is my y1, and we have y minus 0 equals to m, which is 5 half, and then we have the x minus x1, which is 0 as well, all right? And of course, I know you guys can use the y is equal to mx plus b formula, but as I said, this will always work just as a review purpose. Anyway, this is just going to be y equal 5 over 2 times x, which is 5 half x, okay? Well, y is equal to 5 over 2x. I want to get x by itself. In another word, look at this. I can tell you that multiply 2 over 5 on both sides. X will be 2 over 5. Y. And this is what we need, okay? And now, here is the integral that we are going to use. From 0 to 8, and then 10 minus y, and then multiply by 9.8 times 1,000. And we multiply by pi. And for the x, I'm going to replace the x with 2 over 5y inside here. And then don't forget to square that. At the end, you have the dy. And depending on your instructor, for my class, I will just ask my students to use a calculator to compute this, because the setup is the most important part. And if the setup was incorrectly, there's no reason for you guys to do this by hand, right? Focus on the setup. And this is pretty much it. I know I haven't told you guys the answer yet, but this is what you guys are going to do. Calculate this integral with whichever way that you want. Comment down below the first person whoever got the question right. I will pin your comment, okay? Anyway, that's it.